Good. Yep.
Computer's ready.
Go.
Hello and welcome to the latest Cambridge Skeptics live stream. The Cambridge Skeptics are a volunteer organization. We are dedicated to promoting critical thinking, science, and positive skepticism. Oh, we're good. We're still dedicated to promoting critical thinking, science, and positive skepticism in our local community of Cambridge, but also across the UK and beyond. And today, we are going to talk about dating.
Yay!
That's it.
Believe it or not, skeptics know something about that.
Yeah. We do know something about dating. And actually, a fun anecdote while we get the screen sharing set up, because the host has to enable screen sharing, is that when I was an archaeologist, I wasn't working in radiocarbon dating. I was working in stable isotopes, but there were people in my lab working in radiocarbon dating, and there was a guy who was working in radiocarbon, and we started our PhDs around the same time, and he would carry around this notebook that said dating problems in it. And after like 6 months, he's like, I realized that people are going to think I have dating problems. And like, this was obviously like.
And did he?
Well, he was actually married.
6 months to realize, probably yes.
Yeah, exactly. No, it's funny because he was like the first person like of my age group whose wedding I went to, so like he did not have dating problems. But yeah, just like it's funny because it was like pre-incel, obviously, but it like could have been sort of like an incel journal, but it wasn't. So before we get started on the topic of dating, by which I mean, of course, telling how old something is, in case that wasn't clear, I wanted to ask. Sorry, what was that?
Always important when dating.
Oh, yeah. Let's not go there. But why I wanted to ask you guys before we start, what is the oldest thing you have in your house? And I'll start with Sam. What is the oldest thing you have in your house?
I have a penknife that was my grandfather's, who would have been a sort of he'd have been 102 now if he was still alive. But
wow.
Yeah, so he had this when he was a teenager. Well, he had this when he was a teenager, so it's at least like 85 odd years old.
Nice. Andrew, what's the oldest thing in your house?
Well, somewhere in my house, I do have a fossil of a little fish, but I couldn't find that. So I've got this, which I believe is some kind of shot from maybe
cool.
a cannon or musket or some kind. But yes, I don't know. I can't remember exactly what it is.
If you had to guess, Andrew, how old would that thing be? Like, would it be millions of years old? Would it be like 10 days old?
Well, okay. The having it shaped into a ball for use, I'm maybe a couple of hundred at most.
That seems reasonable based on
the actual thing itself. Probably, I don't know, 1 billion or so.
Well, and that's a very interesting point. Like when we say how old is something, we have to define what we mean by that. So that's clearly made out of stone. And so when we say how old is it, do we mean the age of the creation of the material, or do we mean the age at which the event happened and made it into the thing that it is? And the answer is like you can ask the answer to the question both ways, really. Although normally when we talk about objects that humans have made, when we say how old is it, we mean like how old is the event that made it into an object that you're interested in. Like, for example, if I go into your kitchen cabinet and I'm like, wow, how old is this salt? You're going to be like, oh, we've had this box since 1976. You won't be like, well, actually, the salt crystals were formed, because then you're going to be like, what? Like the hydrogen was formed in the Big Bang. Like, that's at some point you end up saying like the fundamental particles that created this element were created in the Big Bang. Therefore, everything is 13.9 billion years old. But we don't do that. Anyways, Chris, what's the oldest thing in your house?
So I had this fossil that I stole from Andrew's house last time I visited.
Is that a trilobite of some kind? Or
Ammonite, I think.
ammonite? Okay.
That's what I would say. I would say I'm not a fossil person. Like obviously, like they're fine, but like that's not my academic background. Not it's not like being a cat person or a dog. Yeah. I mean, like I'm not saying like I'm a cat person. I'm not a fossil person. I am a cat person. We're all cat people here. It's one of the requirements.
That and beards, which
like I'm working on it.
You're working on.
It's still
Trying
not
really hard, dear.
really hard. Yeah, beards are hard. So I wanted to ask you guys, how do you know approximately how, like let's say in the case of Sam, how do you know that thing is as old as it is?
I've been told it.
Yeah.
And there's nothing that I can see about it that would suggest that I've been deceived. Like it's
like
very simple.
It says like iPhone 5 on it.
Yeah, it doesn't say iPhone 5 on it. It's well worn. The nature of the craft doesn't feel modern in terms of, it's definitely, it doesn't seem like there's nothing in the way that it's structured that would suggest that it's been made in the last 20 or 30 years. Like I've seen no evidence that disproves what I've heard.
Yeah. And Andrew, why did you say that your thing, in terms of the date that it might have been manipulated by humans, what information were you picking up on to say, like, I think it's about 200 years old and not like 2 million years old?
I suppose the knowledge I have of history and when that kind of weaponry was used, and
Yeah.
So
and,
yeah,
it was made by humans, so therefore it can't be like 2 million years old.
Yeah. And also, what it was more than likely made for is we're talking gunpowder era, not modern. So yeah, a couple of 100 years old sort of thing, maybe. Yeah. But yes, yeah.
And Chris, how do you think you could possibly determine how old your fossil is?
Well, it's signed by Jehovah, so it must be 6,000 years old.
An excellent point. It dates to the flood, the biblical flood, as we all know. So what we're going to do is we're going to talk about a little bit about how we actually figure out how old some of these things is. And I wanted to start with a little fun game for you guys.
Yay. Do I need my cards?
You do not need your cards. We do not need any cards. That says A, B, yes, no, aliens.
We got more cards while I was away.
Yeah, we got aliens.
So for this, I'm going to show you guys 4 inventions, things that were invented by humans, and I want you to tell me which one you think is the oldest. And what I'm going to do is I'm going to ask each of you. I'll show you the 4 things, and I'll go through each of you. So I'll start with Chris, for example, and I'll say, sorry, Chris, I'm just throwing you under the bus. It's because you were here last time. And I want you to tell me, in 30 seconds, what's your reasoning for why you think one of these objects is the oldest. So you can ask me questions if you want. Sound good?
Yeah.
So, which of these is the oldest human invention? Is it coins? Is it books? Is it a lace-up shoe as opposed to like a sandal? Or is it the wheel? So, starting with you, Chris, tell us what you're thinking. Which one do you think is the oldest?
Oh, wow. Okay. So I'm gonna put coins as probably the latest because you need metallurgy and things to get those working. Books quite late. You need writing. It depends what you mean by books. If we're accepting scrolls and papyruses and things.
I'm not accepting scrolls. So with the book is by definition a series of pages of writing bound together.
Right.
And it's a distinct invention from a scroll, because a scroll you have to like go through the whole thing in order to find the item that you're looking for, whereas a book you can flip through the pages. It's a bit like early hypertext, like it's a bit like really early HTML. You suddenly have the ability to like not go through the whole thing to find the bit that you're looking for.
Yeah, I have used books, thanks.
If anyone else doesn't know what a book is, just
Okay, I'm putting that even later then. So I'm down to the wheel or lace-up shoes. Again, what do we mean by the wheel?
So I mean a circle. Yeah, what I mean is a circle that is used to power movement.
Okay. I'm going to go for the lace-up shoe being the oldest.
Cool. Andrew, what do you think?
Chris made some very compelling arguments there. I think so. I'm with books. I think is probably the most modern. I think in that sort of format. I guess if you're counting with lace-up shoes, the sort of Greek sandals with the straps and stuff like that. That if that counts as lace-up shoes, I can totally imagine that being an ancient thing. I have a strange thing in my head that the wheel is not as old as we think it is. I don't know. Do you know what? I'm just going to go with coins. I'm going to go with coins.
Coins as the oldest.
Yes.
So the opposite of Chris, who said that coins was the most recent. No. He said
possibly books are even newer than coins.
I think some form of coins have been in use for, some kind of coins have been used for a long time.
Would you like a definition of what a coin is?
Yeah, that's a good point. What's a coin? Is it a shell or?
No, well, that's what I was going to say. Is that presumably coins just need to be a token that have a value and are used to exchange for goods and services, rather than being metal.
They have to have a set value, and coins. The definition of a coin is that it represents a consistent value.
Oh, okay.
So presumably that there are coins.
I don't know. I'll
coin is
stick with
worth 10
that.
times as much as that coin.
I have no idea.
Oh, and another important definition for what a coin is that it symbolizes the value. It has an indication on it that tells you what the value of it is.
Okay. I'm going to stick with that simply because I have no idea. I think I'm going to be wrong whichever option I choose somehow. Cool. And so, yes, let's just go with that. And you can tell me why.
I love telling people why. Sam, what do you think?
I think it's going to be the sandal. It's going to be the oldest. I think because ultimately, if you're moving around, you need sandals.
But remember, I didn't say sandal. I said not sandal. I said a lace-up shoe. Oh,
sorry. I must have zoned out for half a second there. So it's not a sandal, it's a lace-up shoe.
On the slide, Sam.
It says lace-up, yeah, but I thought you said lace-up shoe or sandal. Like
okay.
In any case, like I wouldn't be too surprised if Neanderthals had lace-up shoes. Like I think they must have had lace-up shoes. So I'm gonna say that that's still the oldest. I think books are the youngest. It takes too much. You need too much infrastructure for books to be worth carrying, holding, creating. You definitely need an economy. So I think coins must precede it, and I think that the wheel is really handy. So it's kind of a flip flop between coin and wheel for me as to what's second and third. I mean, you had coins without wheels in the Americas.
Did you have coins without wheels in the Americas?
Didn't you? I thought you had coins. We didn't have wheels in parts of the Americas.
They didn't have wheels. I'm not sure they had anything that would be recognized as coinage.
Fine. No, I'm going for wheel as second oldest and coin as third oldest. But I suppose in my head, yeah, I was just thinking of them as tokens or something that has a set value that's easily transported and is representative of the general economic output.
Awesome. Cool. So you guys actually touched on a really important theme in the way that you were reasoning through this, which is that there's a difference between when something is likely to have existed versus when we have evidence that it existed. So what Sam was saying about shoes, for example, well, why might it be easier to have evidence for coins than it might be easier to have evidence for shoes?
They last longer.
Yeah.
Yep, exactly. Exactly. So small, valuable things made of material that doesn't decay very easily, you're a lot more likely to be able to find it. Shoes are probably not very present in the archaeological record. So when we talk about the earliest, when I talk about when this invention occurred, you could argue that really all we can talk about is when we have evidence for it, not when we know it definitely occurred. So, for example, if I take the evidence of books, do you know what the early form of a book is called, or like what the sort of, if a scroll is not a book, what's the nope. It's called a codex.
Codex, yeah.
Codex is the word for like the idea of combining pages together. The plural of codex is codices. So we find lots of evidence for preserved codices in Egypt. Guess why?
It's really dry.
Yep, exactly. Really dry. Gives us a chance to preserve lots of fine organic material, like the papyrus that codices would be made out of. We also obviously find a lot of scrolls and things like that. So there are preserved codices in Egypt. What's interesting is that they seem to correlate with a lot of early Christian writing. So whether that was like a format that tended to be like more preferred by early Christians or something, not totally clear, but like where the evidence is found, it seems to correlate with writing in Greek as opposed to in Latin. And Greek is more associated with early Christians. They're writing a lot of Christian texts in these documents. So the earliest like extant, as in like surviving to this day, codex is from the 4th century AD. But there's indirect evidence for books that's a couple of centuries earlier. Do you guys know, can you make a guess for what that indirect evidence might be?
Is it references in other surviving writings?
It is. Yep. So you've got like I think it was like Marshall or like some Roman writer who's like, damn, these book things sure are handy because you can like hold them in your hand while you're traveling, and like they're so easy to carry. You don't have these like pesky scrolls.
But he didn't write that in a book.
How a lot of ancient writings get passed down to us isn't because we have the exact scroll that Cicero wrote. It's because it got copied by someone who copied it, and often the manuscripts that survive to this day were from medieval monasteries. They got copied so many times. So that's books. The next oldest one is coins. So, and this is where the definition of what a coin is quite tricky. So you're right that there are small objects that can be exchanged for value quite easily. So shells is a common example. That people will exchange shells for items, and in some ways they do act as a monetary system. The difference is that they don't have a set value that is associated and sort of assigned to them with a stamp. So how coins sort of come to be is like, imagine you're going to this marketplace and you're like, I would really like these cows. I have a bunch of grain. I would like to trade you this grain for we've all played Settlers of Catan, right? So this is basically what it's like, except that instead of like having cards to trade, you have actual like physical cows that you've got to like schlep around the ancient world and trade them for the things that you want. And you know what
I think
like,
that game would be as popular somehow.
Exactly. But like, you know what it's like when you have something, you're playing Settlers of Catan and you're like, well, nobody wants my sheep and I really want this ore. And it's hard to do the trade. So you've got the inconvenience of having to have the thing that your person, like to be able to make the trade. Plus you've got to have you've got to be able to like physically carry it around. So then the idea of using precious metals as a sort of in between arose, because they're small and easy to carry. And what you end up seeing before the invention of coins is these then you have the problem, which is like, well, how do I know that the gold that you're carrying is just as valuable as the gold that I'm carrying? There's such small amounts. So we end up setting up like common weights and measuring systems. And you start to see that all over the ancient world, is these little weights that end up getting preserved. And then somebody had the bright idea to sort of say, well, now I'm worried about the quality of the gold or the silver, right? Because could it be impure? Does it just look like silver? Is it really the thing that's valuable? So what they do is they start stamping it to say, I have assured that this is of a certain value. This is a certain amount, standard amount, and standard purity. And that's how you suddenly get the coinage. So like the first coins were really just a way of saying this is a standard purity and amount of this precious metal. And then it goes through this elaborate design sort of evolution where it's like, oh, actually this can represent, this can represent way more value than its actual physical value is.
But is that then? But surely there's like two issues there, in that the gold itself, by stamping the gold, you're saying yes, it has a certain value, but much in the same way that you could just have a bar of gold, or you could turn the bar of gold into a sculpture. It's the same material, but it has two different values. Surely the value of the coin is the value it actually possesses, as opposed to sort of maybe like a banknote, which is distinctly less valuable, but better.
Like you're talking about a fiat currency, and like these days, of course, we don't even have physical money. We just have like electrons moving around the internet, and that's enough for us to say like, I will exchange some of my virtual money for your virtual money. So we've like totally distanced. So we're completely separate from that physical object. But what you see, for example, in the Roman Empire, which is so this, by the way, was happening in one of the city-states in Asia Minor, in present-day Turkey, around 600 BC. This is the first time where we see people using metal this way to denote specific denominations of value. Other places around the world also had what seemed to be independent inventions of currency like this. But what's interesting is like what you start to see later in the Roman Empire is like, we're going to keep producing the same denomination of coin, but we're going to cut the amount of silver in it, and it still buys the same amount of bread. That's what I mean, is that the buying power of the item becomes separated from the material that it's actually made out of. And that, of course, later on gives you the idea of the banknote. But of course, like, I don't know if you guys know about the gold standard. The idea was back when we were all using the gold standard, you were still able to transform your money into a certain amount of gold.
Yeah, because wasn't it the £5 note was £5 of, was it gold or silver, or but it was
it was the gold standard. So that was how currency, until I think it was 1971, was still tied to an actual value. It was just symbolically representing that value, whereas these days it's just purely symbolic, which is cool. So the next one, is it wheels or is it shoes? The answer, so this is where I say it comes down to what the physical evidence is. The answer is that shoes is the next oldest thing. It's about 5,500 years old, so it's 3,500 BCE is where we have the physical preserved shoe. There are actually some evidence for sandals that are a couple of thousand years older than this, which would actually make sandals older than the wheel. But the whole point is I'll show you a picture on the next slide, but like the circumstances that cause these things to be preserved are such unique, rare circumstances. Undoubtedly, there were people wearing footwear before then, but we have no evidence, direct or indirect, that was happening.
Well, I was over the course of this, I've been thinking as to like what would be indirect evidence of shoe wearing.
Good
and
question.
I was just wondering if there was anything that could be identified
Like
from
preserved footprints or something.
Footprints.
I hadn't thought of preserved footprints. I was thinking about whether the shape of the bone changed when you got padding on your feet.
I think you're putting too much stock in ancient footwear technology.
Quite possibly.
But there was that story that I shared with you guys a few weeks ago about medieval shoes and bunions. If maybe that's what you're remembering. There was like a fashion for pointy footwear in the Middle Ages, and a recent archaeological analysis of foot bones from the medieval period found that it correlated with an increase in bunions in the population. Fun fact. That gets us on to the final one, which is the wheel. And the wheel is quite interesting because, again, it's made out of these ephemeral materials, right? We're not making it out of steel or things like that. They're often made out of wood. But we have indirect evidence. And interestingly, it often occurs in the form of toys. So there are children's toys that have little wheels on them, and those get preserved, for example, in graves. And that's often how we have evidence for the use of the wheel, which is, I think, really, really sweet. The other interesting is that the pottery wheel was invented 1,000 years. We have evidence for it 1,000 years before wheeled transport. Which, like, we don't really think about how important pottery is in the ancient world, but I ask you to consider the contents of your recycling bin. Right now, literally 95% of your recycling bin would have been a clay pot in the ancient world.
Including my recycling bin, presumably.
Recycling bin. Exactly.
I'd have had 3 different coloured pots outside the front of my house.
Yeah, like if you've got wine bottles or beer bottles in there, that would have been pottery. Your Amazon box, probably pottery too. It's a ubiquitous and cheap material. There's so much of it in the ancient world. Maybe not 95%, because I guess there would have been like baskets and like sacks and things like that. But anyways, a significant amount of your recycling bin would have been pottery compared to what you use it for today, which is basically just eating. It was a lot more common in the ancient world. And the ability to use a pottery wheel to make radially symmetric jars and containers is a big technological step up. So what we're left with overall, these are the dates in summary. So the evidence for the wheel being used first for pottery, and then about 1,000 years later for transportation. Interestingly, also with the wheel, we tend to have a lot of evidence for the wheel from depictions. So this depiction is from ancient Sumeria from 2,500 BC.
I'm just trying to work out if he's wearing lace-up shoes in that picture.
Yeah, it's
Very fetching hat.
There's definitely boots from the looks of things. They have Velcro?
Yeah. It also looks to me like his fingers are like super dangly. Looks like he's going like that. They're not. It just looks like that to me. So the question is, now that we've thought a little bit about how old stuff might be, the question is, how do we know how old stuff is? There are 2 types of dating techniques. Does anyone want to make a guess or a joke about what they might be?
you sort of touched on it earlier. I guess we have some kind of direct way of dating things and indirect ways of dating things.
That is very good. That's excellent. So we call them the direct one we call absolute dating methods, and the indirect one we call relative dating methods. So in the relative dating methods, by the way, are not incest. I need to be very clear about that. just gonna say. So can you guys think of what an absolute dating method or technique might be?
But like radiometric dating.
Yeah, radiometric dating is an example of an absolute technique, so it doesn't depend on anything else that you might see. What's another absolute technique that we can use?
Tree ring dating?
What are you saying?
Tree ring dating, dendrochronology.
Tree ring, dendrochronology, yep, that's another one where it doesn't depend on anything else. We can count the tree rings directly and work out how old something is. And speaking of rings, yeah, ice cores, I was going to say, so there's other stuff that makes that goes through annual cycles like that. There's another thing of, have you ever heard of lake varves? A little bit of varving? No, varving?
I have no idea what it is.
That never happened in my dating history.
Well, you're missing out. So that's a similar process where there are certain types of lakes that, because of the way they go through the seasons, these sediment deposits on the bottom in layers, and those get compacted and compressed over time, and they're full of organic material, and you can again count the rings similar to ice cores and tree rings. There's another type of absolute dating that can be used for some of the objects that we talked about on the previous slide. How would you be able to absolutely date? Let's say, for example, you come across the ruins, the foundations for a shed in your garden, and under the shed is a coin. How can you use that coin to determine the date after which that shed must have been built?
Yeah, because ultimately the shed presumably can't have been placed on a coin that hasn't been invented yet.
And how do you know how old the coin is?
Got the date on it?
There's a date on it. Yeah.
Well, yeah.
So we use that a lot because a lot of what we're interested in is human history, and there will often be the objects that have the absolute date known. Then there's an interesting question about, like, we obviously weren't all using the same calendar for a lot of human history, so how do we calibrate the different calendrical systems that we might have been used? But quite often you're talking about a documentary record. It'll be, on the seventh day in the reign of this king in this month, this thing occurred. And it will be like, wow, we have evidence for this thing occurring. I bet that's related to that date that they said it was. Yeah. So what about relative dating? What are some examples of how you might use relative dating? You guys are just thinking about incest. I know. I'm sorry. It's really hard for you.
No, but
for the record, I am not thinking about incest.
For a change.
Yes.
So I was thinking about I understand that from ice cores we can get an understanding as to how the atmosphere has changed, and then if we found pockets of sealed air in other things, could we then use the composition of that air to compare it to the kind of the composition of the air on record and just go, oh well, this actually is consistent with this time frame?
Theoretically, yes. There is an example of how we can use a similar technique, and that is, do you guys remember when that volcano from Iceland erupted? Why were all the flights grounded? Do you remember?
The ash
everywhere. Yeah.
The ash in the air. The ash was spreading all around like the northern hemisphere because of that volcano. And I don't know if you remember, but there were like even a couple of days where like people were finding it on their cars and things like that. Like there was this fine layer of ash. That ash, we know, like from newspaper records, fell on a single day or like for a couple of days. It also, ash, volcanic ash is actually a glass, and there's a bunch of trace elements that are, part of that glass, which is a reflection of the volcanic conditions that it erupted in. Theoretically, it's possible to tie that ash chemically, to sort of use a chemical signature to say that this ash is from this one eruption. So you could say, for example, in like 1,000 years' time, when we come across that layer of ash somewhere, we can say, this was the layer of ash that fell on this particular day. Now, I will say that it's not always possible. Like if you're like, yeah, but that ash got moved around, like in 1,000 years, we've cleaned the streets, like blah, blah, blah. It won't be present like literally everywhere on Earth. But there will be some, imagine you're a serial killer and your dad dug a grave on that day.
Nice example.
Just saying that layer of ash would be preserved there. So if an archaeologist came across it, that's a context where they could say, wow, we found this ash. We know when this happened. And we know lots, like Iceland has lots of volcanoes. Iceland's a very common case where this technique gets used.
The serial killers or the volcanic data?
The volcanoes, not serial killers. Don't do that. So you can use these kinds of ash layers, kind of in the way that Sam was saying about the pockets of air. You can chemically identify the signature. And it's
sorry,
go on.
I was going to say fossils, index fossils. Would they count as a relative?
So like, what would you be doing in that context?
Some kind of archaeology, I guess. Oh no, paleontology. Paleontology. That was a close one.
But if you're
rage quit.
Yes.
Presumably, like you can't. Presumably, the idea is that of an index fossil is that it's a species that was around for a relatively short period of time and is relatively distinctive. So, like, you're not going to use shark teeth to identify anything because they've been around for hundreds of millions of years, I think. So they're not really very useful because they're just ever present. Whereas if there was, let's say the T-Rex was only around for 20 million years, well, you go, okay, that anything that's buried alongside a T-Rex was also there at the same time. And overlaps.
Exactly. Well, yeah, so you've just described relative dating exactly. I want to show you a little picture of what this can look like. So, there we go. So this is an example of, you'd call it a section. So it's a vertical slice through the earth, and what you're seeing, all the different possible layers. So at the top, there's pebbles, there's kind of then a reddish layer, there's a big, thick black layer, underneath there's something fine, et cetera, as it goes down. So what this looks like kind of schematically, you'd draw it kind of in a picture like this, and you'd say, okay, there's these different layers. We can, we think that a single homogeneous layer represents a single event. And we have no way of knowing that event could be weeks, it could be hours, it could be years, right? We don't know, but we can say that that's a single event that happened, then something changed and something else happened. So what Sam just said is really important. We assume that everything from the same layer has the same age. And where these two techniques are very powerful is where we can use absolute techniques to reinforce relative techniques and vice versa. So we can say, hey, let's radiocarbon date everything from layer 4. And we can, if they all have, statistically, similar radiocarbon dates, then we say, wow, like our theory of this layer formation is correct. And then similarly, if we say find something else that's really similar to layer 4, we can say that it probably has the same radiocarbon date that we dated in another part of layer 4. But we can also do interesting things like if we know that layer 4 is younger than layer 3, because of course stuff gets built up on top of other stuff. And let's say we don't have anything that we can radiocarbon date in layer 3, but we do have stuff that we can radiocarbon date in layer 2. We can say, well, even though we don't know how old layer 3 is, we know that it's between these two dates. So the relative dating, it's very dependent on this science of being able to understand the layers that stuff gets put down in. It's a bit like, have you ever left your laundry bin for a really long time and you're looking for a piece of clothing that you wore a couple weeks ago, back when it was really hot? And
no, I have never done that, Rebecca. And please do your laundry more often.
Well, I'm just saying. So let's say it's been a couple of weeks. You remember it was really hot a few weeks ago. You're looking for, where did that shirt go? Is it in my laundry? I know that it was from a couple of weeks ago when it was really warm. And you're going
to be fair, I don't have enough clothes to do that. I have to do my laundry once a week.
Chris and his caps. But so let's imagine you're going down and you're going through like this layer of like woolly socks and jumpers, and then suddenly you hit a layer of like shorts and t-shirts, and you're like, I must be getting, like, this is now the deposition event that represents the warm couple of days that we had a few weeks ago. It's just that. Do you guys know what it's called? The science of understanding layers, not laundry, just the sort of sediment layer study. Do you know what it's called?
No.
It starts with an S.
Sedimentology. Dendrochronology.
Sequence. No.
It's called stratigraphy.
Ah.
Yeah. So it means like stratus as in like flat things. So layers, and graphy meaning writing. So it literally means like reading the signs of the layers. Fun fact. So let's get back to what I wanted to do was talk to you guys a bit about how we talked a bit about how relative dating technique works, but one of the absolute techniques that Andrew mentioned right at the beginning are radiometric methods. So I thought maybe it would be useful to tell you guys about how some radiometric methods work. What's a radiometric method that you've heard of?
Carbon dating.
Yeah. Carbon dating. Yeah, radiocarbon dating. You know, it's funny. Everybody that I know who works in radiocarbon calls it radiocarbon, and only people who are outside the scientific discipline call it carbon. I guess it's because like there's lots of different types, like there's different isotopes of carbon, and it's the radiocarbon that's the most important one. I don't know, but interesting fact. So how does radiocarbon dating work? Does anyone want to have a go at trying to explain it?
I'll have a go.
To do with the ratio between different types of carbon. That's about what I know.
That's good. Different types of carbon. We got different types of carbon. What else?
So there's different types of carbon, but the proportions are not even. So there's a sort of a ratio line, and so knowing what the ratio is, you can work a certain distance back, but it's not quite.
Why
level.
are the what, Sam? You're drawing a diagram here. What's on
the ratio of carbon 14 to carbon 12?
What's on the x-axis?
Time.
There we go.
Time. How far back you are versus the ratio, and
what causes that ratio to change?
Carbon 14 decays into carbon 12
yep.
over time.
Radioactive decay. It actually decays into nitrogen 14, which then goes into the atmosphere, but that's fine.
Well, fine. No, it's in any case, it decays. It's no longer It's no longer carbon-14, whereas the carbon-12 is stable, and so it doesn't decay. But so the ratio will get lower and lower as you go further and further back in time. But because it's relative to the amount of carbon-14 that was around at the time as well, it's not quite as simple, was it?
What do you mean? What do you mean around at the time?
Was present and available to.
I could just say the same thing in a different way.
the ratios of carbon 14 to 12 that were present when that thing took on that, because carbon dating is just for living things, isn't it? Because they
so let me. I want to ask you two questions here. Actually, I want you to tell me 2 reasons why radiocarbon is such a useful radiometric technique for archaeology. I want 2 reasons why.
Because it deals with fairly short date, relatively short date period.
And do you know,
as we learned from you, is just people. So we can't go back too far.
And they lived relatively recently. Now, Dr. Osiris in the chat has said it only has a maximum range of 50,000 years or so, which is approximately correct. Do you guys know why that's the case? Why can't it work for millions of years?
Because at that point, is it an element of random, either randomness or contamination? Like at that point, it's just
the rate of decay.
There's so little signal to noise.
Yeah, you guys are getting it exactly. It's the rate at which the radiocarbon decays. And do you know what the word is for that? That rate. A half-life, exactly. Do you guys know what the half-life for radiocarbon is? I don't know why, but ask you. It's 5,730 years.
I was about to say that.
Yeah. So what that means is that after, if we have a sample of radiocarbon and we have 100 atoms of carbon-14 in that sample, after 5,730 years, there will be 50 atoms. And after another 5,730 years, there will be 25 atoms. And now I've realized that I haven't gone to base 2, and my fractions are going to start to get bad. So then we've got, after another period of 5,730 years, we've got 20, what did we were at 25? So we're at 13.
Call it 12.
But actually, that's a really important point, because you can't have half an atom decay. And radiocarbon is what's known as a stochastic process. So we don't know any individual atom. We don't know which individual atom will decay when. All we know is that on average, this is how fast the decay is going to occur.
And after 50,000 years, you're down to about 0.25% of the original.
Exactly. Also, do you know how much radiocarbon is present relative to actual carbon?
No.
It is a very, very small amount. So we're talking, like when I said 100 atoms, like I wasn't joking. We're really talking, there can be, obviously it depends, it's a percentage, so it depends on the actual starting material. But what it means is that the contamination can be a really big issue when you're dealing with any kind of sample preparation to do with radiocarbon. As an example, so I've worked in both stable isotope labs, radiocarbon labs, and earth sciences labs. In earth sciences, we typically measure things that are parts per million or parts per billion. So that's already 1,000 order of magnitude between those differences. So like, put it another way, if I have a liter of a substance, picture a 1 liter bottle, and I put 1 milliliter into that, that is 1 part per 1,000. If I then get another bottle, that's another liter, and I take 1 liter out of that and I put it to that, that's Yeah, milliliter, sorry, into the
So
liter.
do homeopathists do this? Because that would get better for them, presumably.
Oh,
Well, that is exactly how they do it.
I don't even know how radiocarbon and homeopathy would work. But what I was gonna say is like, so in earth sciences, you know, like when we measure like trace amounts of metals in a substance, like for example that volcanic glass that I mentioned, we would be measuring parts per million or parts per billion trace amounts in there. In radiocarbon, we're measuring parts per trillion. It's another like set of orders of magnitude away level of like, it's not precision, but it's like the smallness of what we're measuring, the ability to contaminate it is very, very high. And I'll get on to how we get around contamination in a second. Here's a question for you guys. If radiocarbon decays over 50,000 years and the Earth, you know, like so that there's almost nothing left after 50,000 years, and the Earth is more than 50,000 years old, where does the radiocarbon come from?
I've always wondered that, but I've never at a point where I'll be able to look it up. My presumption is that it comes from other decaying atoms. Like, do other things decay into carbon-14?
No, but you're not far off. So the overall picture here is that carbon-14 is produced by irradiation of nitrogen-14 in the upper atmosphere by cosmic rays. That's the source of all of the carbon-14 that we have. Yeah, cosmic rays. And then what happens? So it means that you have this loose carbon atom flying around the atmosphere. He's like, oh my God, 5 seconds ago I was nitrogen, now I'm carbon. What happens to a random carbon atom in the atmosphere, guys? Well, you can't just breathe it in because it's a random carbon atom. What happens?
No, but it gets sucked up into something.
It becomes carbon dioxide. Yeah. And so all of the carbon in the atmosphere, basically, I mean, there'll be bits of like methane or whatever, other organic gases, but basically it becomes carbon dioxide. So then how does the carbon get into you? If I were to radiocarbon date Sam's bone, how would the carbon get into him from the atmosphere?
From breathing and eating and stuff like that.
What do your lungs do? Do they take in carbon?
No.
No,
so it is eating.
Not just the eating.
So your carbon comes from your food. You've heard of carbohydrates, right? Yep. The carbon is also found in fat too. Where does that carbon come from?
I really regret not revising for this now. I didn't know there were going to be so many questions.
I'm guessing we get our carbon from eating animals. Animals get their carbon from eating grass and plants.
And how does the
plants
grass
do use CO2?
For photosynthesis. There we go. Yeah. And welcome to the carbon cycle. You have understood it. So that's exactly it. So what's happening when you're in, you know, when an organism is alive, is it's basically in equilibrium with the atmosphere. So you right now have the same atmospheric, you have the same concentration of radiocarbon in all of the carbon in your body. It's the same as the atmosphere. When you die, though, you stop taking in new carbon. So the amount of C14 that you have in you gets depleted over time. By the way, we call it C14 because it has 2 extra neutrons in its nucleus, and regular carbon is carbon-12. There's another isotope called carbon-13, and that just has 1 extra neutron. Yeah, so that's how radiocarbon works.
So to ask the question that always comes up whenever you're talking about this sort of thing with certain people on the internet, how do we know what the ratios were to start with? Because obviously, if way back in the more than 50,000 years, obviously, back in the past, the levels of carbon-14 in the atmosphere were drastically higher. Then we would be we would expect to find more in a sample. Does the initial starting amounts of the carbon-12 compared with the carbon-14 in a sample matter as much, or?
Oh yeah, that's the most fundamental assumption, is that you know what the starting ratio was. So we know what it is today, but you're exactly right. How do we know what it was in the past? So the first question is, remember, what controls the amount of C14 in the atmosphere? What makes it happen? It's cosmic rays, right, from outer space. So like one question is, do we have any evidence for massive fluctuations in the rate of cosmic ray production? You know, are there any astronomical reasons why that might have, like, was there any like massive thing that has affected us in the past that we've suddenly got a different amount of cosmic rays? And the answer is like, no, we don't seem like, there doesn't seem to be anything. But there's another question, which is like, there is still going to be fluctuations and things that happen over time. Is there any way that we could measure it?
I think Sam touched on it. Is it the air bubbles in the ice and stuff? Is that a bit of the atmosphere, or?
That would be one example. Then the most common way is also through dendrochronology. So basically, you find something that has those layers that I mentioned. So if it's lake sediments are very common, tree rings is another example, and you measure the amount of carbon in these tiny little layers, and that helps you build up this picture. So I'll show you on this slide. What you're going to see is the radiocarbon date compared to the actual date that we know from counting the layers. So if it was perfect, if there was no fluctuations over time, you would see a perfectly straight line. Instead, this is what you see. It's a wiggly line. And what's interesting is, like, over here around between 1000 and 1200 AD, calibrated age AD, you see the curve is quite flat.
Yeah, that's the bit I was trying to.
Yeah, so what that means is that if you have a radiocarbon date, or like if you look on the vertical axis, if you have a radiocarbon date around there, it could actually correspond to a very wide range of calibrated ages. And that's just how, like, there's a fundamental uncertainty in how that works. So I'll show you guys, like, this is how it would look. So you get your radiocarbon age estimate. That's quite a nice statistical distribution. That's like, we're counting the atoms, and we know that there's a range that count could represent. There's always going to be uncertainty, right? This is like your standard measurement uncertainty. But then we compare it to the part of the calibration curve that it's in, and what you see on the gray part on the bottom is the statistical probability region. In this case, it's the 95% confidence interval. So one sample out of 20 would fall outside of this range. But you can see that that's what's being highlighted here with the brackets on the bottom. So you actually have 3 distinct, like, zones of probability that this date could correspond to, which is interesting. And then that's an example of how tree rings work. So you don't just have to have one tree that's super old. You can actually use it a bit like barcodes and compare layers of trees going back, because the factors that affect the thickness or thinness of the tree lines are consistent over a fairly large geographic area. So if there's a drought, the tree rings will be very thin. If it's a very wet year, the tree rings will be thick. So you can use software to compare these barcodes and line up the different tree ring sequences. And we're able to build chronologies that go really, really far back because of this.
This is how we do gene sequencing as well.
Yeah.
The DNA is spliced up to lots of little bits, and they have these like many overlapping sections to create this one long bit for each.
So to ask another question about this, how do we know that the tree rings represent yearly growth rather than just hot and cold periods?
Yeah, so it doesn't work for all trees. Like, for example, trees in tropical regions don't go through this annual sort of growth cycle. But like, so maybe you can imagine you just observe it 1 year from the else. So you take a slice through a living tree 1 year, Then you compare it to the slice 5 years later, and you're like, oh, yep, we got 5 more rings than we did last time.
So you basically find trees where you know that the rings represent yearly growth patterns and use them as your.
So it's a biological fact about trees. They might occasionally like not lay down new bark every year if, like, for example, they're stressed or things like that. But like, you can observe trees under a microscope. This is how they grow. They grow outward from a sapling by laying on new growth every year.
Isn't it like only the outside of the tree is actually alive? Like the inside of the tree isn't.
That is beyond my level of expertise. That is not.
I'm sure there's something where actually it's only the outer edge that is alive, and so
isn't that like a
the
metaphor
inside
for
can't
human
grow.
beings? Like we're all dead inside. Is that a metaphor?
No.
So it's just me.
I don't think trees are depressed.
What I was going to show you guys, just to end with, you remember those shoes that I showed you guys at the beginning? So these are the actual shoes that were found on that dig. This is the paper that the radiocarbon dates were presented in, and this is what it looks like in an academic paper when you report a radiocarbon date. So on the left-handmost side, these are different ID numbers. So you can see OXA for 3 of them and another UCAMS for another. That means that's just a code to indicate what lab they're from. So the OXA ones are from Oxford, which is one of the like leading labs in radiocarbon. Obviously, I'm a bit biased, but what you can see is you've got the material that they dated, and then the next column, date. That's the statistical date that came out of the atom counting machine, which is called an accelerator mass spectrometer. And they're literally counting individual atoms. But you know how we said, like, when you get down to like really small amounts of what's left, there's such a tiny amount left. Like, you know, when we got to the example of like it's 12 and a half. Well, what if I see 12 atoms? Like, is it 12 or is it 13? Where do I put it on the date side? So that's where we get this uncertainty range from. So 4725 plus or minus 32 years. Those, by the way, are years before present. Because we realized as a community that we had to have a consistent way of reporting these dates. Confused. So when we all have the same year that we use as the present, and we just fixed it. Do you guys know what year that is?
Was it? It's 1940? 1900?
No, it's 1950, actually. I would have thought that you would have said 2000, because when I was learning this, I was like, why isn't it the year 2000? It makes the math so much easier. The guy
No, but it's something to do with atomic bombs, isn't it?
No. It's to do with when they invented it. They were in the 50s, and they were like, let's just assume that no one will be using this in 50. Like, I have no idea what they were thinking. It makes the math a lot harder. So there's other things that they're reporting here that are to do with the chemistry of the pre-treatment, which is basically ensuring that, like, yes, we've definitely got pure carbon here that we're working with. And I won't go into the rest of it. And then this is what it looks like after they've calibrated it. You can see those gray mountain shapes again, which is to do with the calibration. What they've done here is they've actually combined these three, the top 3 dates, the 3 leather dates, which are for the shoe directly. Then they've done the calibration for the grass separately. So that was a sample of grass that was associated with the shoe, but obviously isn't part of the shoe. And what you can see is that those dates are broadly consistent with each other. So what you might be able to say is the top one, the shoe combined date, maybe we can ignore this statistical probability, the younger range around 3400 BC, because it's not the same as the grass date, and we assume that the grass is from the same period. So anyways, it gives you a couple of different options for the date. Then what they're doing is they're comparing it to, do you guys remember the Iceman that they found in the Alps? Yeah. So he also had shoes. So they're comparing it to the radiocarbon dates from him, and they're saying, look, it's definitely older.
Cool. So we have a question in the chat, which I don't understand. So
That's what Sheldon's saying. So if C14 is created by N15 subject to cosmic radiation, I'm assuming the current magnetosphere is only slowing the conversion rate, hence the wiggly slope. But what was the mass event? So there wasn't a mass event. If you're talking about like why the curve got suddenly flattened, the answer is we don't really know. It's like or at least I don't know. There's a couple of reasons why the radiocarbon curve fluctuates, and it'll be due to things like just changes in the rate of cosmic rays hitting us, as well as things like changes in like the rate at which carbon is getting deposited in the earth. But basically it's random. There's other sort of climatic things that might be happening. So for example, it takes about 400 years for carbon from the atmosphere to circulate into the ocean. So the ocean is always 400 years older than the atmosphere. Yeah. So if, for example, that process that affects that thermodynamic equilibrium changes slightly, then you'll be seeing slightly different radiocarbon dates if you're measuring stuff that's in the ocean, and all of that has to be taken into account in calibration.
And did, out of curiosity, would things like, so I know there was a mini ice age that slowed down a lot of growth. Would that have affected, because there's just less uptake of carbon?
Yeah. And those things do kind of correlate with that. But to be honest, I don't know. My answer is like to shrug my head and be like, thermodynamics. I don't know. Stuff to do with isotopes, thermodynamics. That's my answer.
I think one of the things which you kind of covered, but I think is worth saying, is that obviously there's lots of different dating techniques. There's lots of different radiometric dating techniques.
Yeah.
One of the things that's very useful is how they overlap. Like you talked about using the tree rings to back up the carbon dating, things like that, and known events to do. But you can use a lot of arguments come up about, well, we can't trust carbon dating or we can't trust this method. But it's when you use all the methods together and you get a consistent pattern that it's like, well, if that one's wrong because of this reason, then this one can't be wrong for a different reason. And so, I don't know if you want to say any more about
and I was just going to add that what's amazing is that we've got a suite of different elements and isotopes that we can use with different half-lives. So some, like strontium rubidium decay has like a half-life of like, I don't know, several million years or whatever. Like it's huge. I don't know. I'm an archaeologist. I don't know what the stuff is that old. But it means that you can use it to date much older things. And obviously there you're dating the formation of rocks, the crystallization of the minerals in rocks, because that's what stops the strontium from just like floating around and being like, well, whatever. You suddenly say like, stop moving around. I'm a crystal now. And then you can measure the radioactive decay that's occurring from that moment onwards. But it means that we can date a wide variety of events. And if we look back in human history further, say, than what we can do statistically with radiocarbon dating, we can use other radiometric isotopes. They won't be as useful because I'm sure I'm biased. They're not as useful for dating human events directly because they can't tell us about organic remains directly. So like they can't be used for bones directly. But what you can do is when you combine it with your layering technique with that stratigraphy, you can date, say, a rock layer above a fossil and a rock layer below a fossil and give you a date range for when that fossil was formed.
Cool. It's really interesting.
Do you guys have any other questions about radiocarbon or other dating techniques? Cool. Well, that's all we got.
You've blown our brains a little bit.
Yeah, I'm confused now. It's currently 1950 and the ocean is 400 years older than the atmosphere. I don't know what's going on anymore.
Surprise. Wait till I didn't even tell you guys about the bomb curve. Sorry. So, guys, what are we doing in 2 weeks? We're having another talk.
Yes. Oh yes, we're gonna have
Talk.
a
Excellent.
conspiracy off.
We're having a conspiracy off. So we are going to be debating each other about what is the most dangerous conspiracy theory. If anyone has any options they'd like to submit us for ones that we should consider, we haven't all decided on what conspiracy theory we're going to
Promote. Is promote the correct word?
promote.
Argue for,
What's the verb that we should use there? I don't know.
represent.
Represent, yeah.
That sounds worse.
Yeah. Anyway, so that is all for tonight. We hope to see you in 2 weeks. In the meantime, please enjoy critical thinking.
And dating.
And dating. Please use critical thinking and dating.